In this lesson, we're going to be learning about rotational symmetry. So what we're going to look at is what is rotational symmetry and how to apply it to certain objects. So let's start off by what is rotational symmetry. A shape has rotational symmetry when it coincides with itself after a rotation of less than 360 degrees about its center. Now, we could do some calculations here to figure out what is the order of rotational symmetry. And that's another definition you must know. The number of times a shape coincides with itself during a rotation of 360 is the order of rotation. So let's take a look at this shape here. We have this kind of plus sign to figure out what is my rotational symmetry and what is my order of symmetry. So first thing we're going to do is we're going to trace my shape. So I trace it. Try and get as good as I can here. Okay. Now that I traced it, I am going to rotate it. So let's see how many times we could rotate it, and that will give me my order of rotation. So let's first see if we could rotate our traced image around the center to see if that image will coincide with my original image. So I'm going to, right here, rotate it, and if I rotate, whoops, that's my original image. So I'm going to rotate my traced image, and I look right here, it coincides with my original image. But I can continue rotating, and it will coincide more than once. Okay, so the fact that it coincides more than once means we have an order of rotation greater than 1. So let's see how many times it will coincide with itself. The image, our traced image, when we rotate around the center, will coincide with our original figure or shape. So I look at this, it coincides once, twice, 3 times, and then 4 times back to the original. Most things always will do it once, which is we'll learn later, it's an angle of rotation of 360, but this one does it 4 times. So in this case, I know my order of rotation is equal to 4. So now that we know what order of rotation is, we could figure out our last definition that we'll need to know today so we could do our problems, and that is the angle of rotation of symmetry. Now what angle of rotation of symmetry is the degree or the angle of what we could rotate an object so then it will be symmetrical. So in order to do this, we take 360 degrees, because that's the whole way around, and we're going to divide it by the order of rotation to figure out the degree of which we could rotate something so it is symmetrical again. So when I rotate it, my traced object coincides with my original object. So from our shape before, we learned that the order of rotation is 4. So what is the angle of rotational symmetry? In this case, my angle of rotational symmetry is going to be equal to 360 degrees divided by 4, which is equal to 90 degrees. So now I have 2 other shapes here that we could trace and find the rotational symmetry, but the lines here kind of helped us with it. So if I was to trace this triangle here, I would tell that it has an order of rotation of 3. So now I want to find out what is the angle of rotational symmetry. So we're going to look at that. My angle of rotational symmetry is equal to 360 divided by, in this case we have 1, 2, 3 rotation, order of rotation, so it's going to be divided by 3, which is equal to 120 degrees. Let's take a look at my next one here, this pentagon. In this case, we have, if I was to trace it and rotate it, I'd find out I have an order of rotation of 5, because we have 1, 2, 3, 4, 5, as it's a regular pentagon, and we would do the same thing here. My angle of rotational symmetry is equal to 360 divided by 5, which is equal to 72 degrees. So once again, what that means is this shape, this pentagon, if I rotate it 72 degrees, it will be symmetrical to my original shape. So I could rotate 72 degrees how many times I want, and it will always be symmetrical. So let's have a look at a couple more examples to see if we can find the order of symmetry and rotational symmetry. So here's my first one. I'm going to use a ruler and tracing paper to trace it to help me find my rotational symmetry and order of symmetry. So I'm putting my tracing paper over top, and I'm going to quickly trace this. So now that it is traced, I'm just going to put my pencil right in the center and rotate this to see where they are symmetrical, or how many times. So I rotate, and I look what my order of symmetry is first, and I rotate it once to get it symmetrical, and then I rotate it. I have an order of 2, so twice am I symmetrical when I rotate it 360 degrees. So looking at this here, I know my order of rotation is equal to 2. Now what that means is that my angle of rotational symmetry is equal to 360 divided by 2, which is equal to 180 degrees. Now let's take a look at my second example. So once again, I'm going to trace this shape with tracing papers. Okay. And I'm going to put my pencil in the center and rotate it and see how many times I can rotate it. So in 360 degrees, how many times will I have an order of symmetry? So I keep on rotating and look at this, and I haven't found any yet. So I continue rotating, and I find out I have to rotate it completely 365 degrees for it to line up. If you notice, my eyes shifted a bit, but it's 365 degrees. So my order of rotation is equal to 1. That means my angle of rotational symmetry is going to be equal to 360 degrees divided by 1, which is equal to 360 degrees. And that is just how we find our order of rotation and our angle of rotational symmetry.